Let's talk transformers. Transformer, switch, terminal strip, contactor. All right, we got 240 volts coming in, 24 volts on our secondary coming out to our switch. What is it? It's going to turn on our coil for our contactor. As you can see, when I turn on the switch, the plunger comes in, allows 120 volts to pass through to turn on our light. All right, so let's talk about it. We got our 480 volt primary coming in to our dry type transformer, and then our secondary coming out of the transformer to our 120 208. Okay, as we all know or should know, we need to be able to read and understand a nameplate or manufacturer's instructions. So on this transformer, this is a 75 kVA or 75,000 volt amps. It is a 60 hertz cycle, which is our electricity cycle that we use here in the United States. We have 3 pH for 3 phase, and then our primary, and then our secondary, primary 480, and then secondary 208. Now our actual wiring diagram, we have the primary coming in as a delta being a triangle, H1, H2, H3, which is your brown, orange, yellow. Our secondary being a Y, a WYE, X1, X2, X3, and our XO, that is our neutral. So we have our primary 480 is delta coming in to our secondary, which is our Y12208. And then last thing to notice, there's another 3/4 inch conduit that comes up and around, and it goes to our building steel. So our building steel is going down through each floor and tapping off each transformer, and then eventually going into our concrete encased electrode, which is our foundation that has rebar in it. And from there, it actually goes to direct earth. All right, so we have another type of dry transformer here. Just want to go over some of the fundamentals of what makes a transformer do what it does. Right here, we have the different taps for each coil, and those allow you to change the voltage depending on if necessary. So going over this, the XO, which is our neutral, and then our primaries and secondaries. You can tell the difference between the primary and secondary just based off the size of the conductor. So we know that this small one is a primary because the voltage is high, but the amperage is low. Whereas on the opposite, the secondary is much thicker of a conductor, so you can tell that it's larger and more amperage, less voltage. So you don't even have to understand or know the labeling, right? Like this one, all the labeling is gone, more or less. I just put some stickers on there. But you can still tell just by looking at the windings. You can also tone it out with your multimeter if you can't tell by the windings. All right, that's it for today, guys. Hope you have a great rest of the day. Have a good weekend, and I'll see you next time.